Lesson 3.2, Logarithmic Functions. Our logarithmic function is in the form f of x equals log base b of x. So this log base b, this is the operator, like a plus sign, or if we're thinking trig functions, sine or cosine. It is just telling you what we're doing with the x. We're doing a logarithm with base b of x. By itself, it's meaningless. Logarithms are inverses of exponential functions, so they undo each other. They're opposites of each other. So log y equals log base b of x has the same relationships between x, y, and b as x equals b to the y. Notice the base is there. Y is the exponent. So in a logarithm, the logarithm equals the exponent. Logarithms are exponents. Logarithms equal exponents. Thus, logarithms have the properties of exponents. So to evaluate logarithms, you have to think, what exponent, since logarithms are exponents, what exponent of the base gives the big number? Select log base 5 of 25. So you have to think, 5 to what gives me 125? Oh, it's 5 cubed is 125. So the answer, the logarithm, is the exponent, 3, because 5 cubed is 125. How about log base 2 of 1 over 64? So again, you're thinking, what exponent of 2 gives me 1 over 64? Well, I can see the base is reciprocal. We were 2, now we're 1 over 64. So the exponent would be negative because it was reciprocal. And then 2 to the what power is 64? You may have to try a few in your calculator. And it's to the 6th. 2 to the 6th is 64, and it's negative because it's reciprocal. But our answer is the exponent. Logarithms are exponents. So our answer is -6. You can use a calculator to evaluate logarithms, but most scientific and graphing calculators only have 2 logarithm buttons. We have log, which just looks like log on your calculator, and it's log base 10. Base 10. If we don't write a base, so notice here the base is missing, it is 10. So if it's just log, it's log base 10. The other one on your calculator is ln, and it stands for natural log, and it's base e. And we write it ln. So if it's ln, it is log with a base e. So try using your calculator to evaluate log of 300. Okay, so I'm going to hit my log button and then 300. Look at that, I get 2.477. Make sure you can do it on your calculator. There's some properties of logarithms. Log base b of 1 is 0. So what's this come from is, remember, logarithms are the exponents. So b to the what power equals 1? Well, 0. The exponent is 0. Anything to the 0 is 1. Next one, what exponent of b equals b? Well, it would be b to the first. And then, what power of b gives me b to the x? Well, x. So what this is saying is if we have log base b and the base b, these essentially cancel out, and you're just left with the x. And if, because they're 1 to 1, as long as you have log of the same base, then the things inside the logarithms have to be equal. So let's try some examples. Simplify log base 5 of 1. Well, using the first property, log of base anything of 1 is 0. How about the next one? Let's see. Those are the same. The exponent is 1. That equals 1 using the second property. What? This one looks different. But we still have base 8 and log base 8. Base 8 and log base 8, when they're like that, they're inverses. They cancel out, and you're just left with 30. That's like the third property. So let's use these properties to solve this little equation. All right, notice the log base 3 and the log base 3 are the same. Since those are the same, the things inside the logarithms also have to be the same. Subtract the 4 and take a square root. Now when you're doing a solving and you take a square root, don't forget the plus or minus. So it looks like x would be plus or minus 5.